Hi, this is a follow-up to my previous video, link in the description, on making kaleidoscopes in P5.js. This kaleidoscope looks different than the last one we looked at, and it looks a bit more like a physical kaleidoscope in that when you rotate it, the motion of the objects has some inherent gravity physics to it that look more realistic. You can see different motions in the objects, and they tend to settle, which is a pleasing effect. So they can go fast, and then if you spin it, they go fast, but then they slow down as they settle, which is a nice effect. If you compare it to the previous kaleidoscope, the Rose Kaleidoscope, this was based on a particle system which uses something called the Rose equation. Let me turn off the blur, which is, more mathematical in nature. The particles are moving at a different speed, which is nice, and you do get some nice effects. But real kaleidoscopes don't do this unless maybe they have an LED screen on one end, which would be cool. So, but you can still get some nice effects with this if you turn up the blur and so on and so forth. But that's not what we're doing in the kaleidoscope we're discussing today. The object cell in the kaleidoscope we're discussing today is a bit more like this simple gravity simulation where I've got a bunch of balls and I can change the amount of gravity and I can change the direction of the gravity. And that's basically what we want happening in our kaleidoscope to get those gravitational effects. The way I'm accomplishing this is using a library called matter.js. I'm going to point to a couple of good Daniel Schiffman videos that talk about it, how to use it with P5.js. And I'll just briefly show the code where I'm using it. When the objects are initialized, you create these bodies that go into the physics engine, and the bodies keep track of the positions and rotations and velocities of the objects. And then you can change the gravity and the objects do interesting things. When you set up the objects, there's two parameters you can play with called friction and restitution. Friction controls how much energy is lost when the objects collide with each other. I usually have it set fairly low. And then restitution controls how bouncy they are. So if you have restitution high and you change the gravity, you get more bounces, basically. There's so many balls in here that they don't have much room to bounce around, but you get the idea. So I usually have the restitution at about 0.6. You don't get a lot of bouncing inside kaleidoscope object cells. Changing the gravity is essentially like changing the viscosity. So if the gravity is high, it's more like the objects are floating in water. And if the gravity is low, it's more like they're floating in oil. And I like oil for kaleidoscopes, mineral oil, because it does slow down the objects. So I usually have the gravity right around there. And that works pretty well. And it's close to what I want. So in the kaleidoscope, we're using a little fancier version of that. If I turn off the mirrors, you can see it. So the differences here are that although the objects are all modeled physically as circles to keep things simple, I am rendering them as, I'm going to turn off the blur so they're easier to see. I am rendering them as stars with different numbers of points and randomized inner radiuses. So you get these sort of spiky looking ones and also less spiky looking ones. But they're just actually balls. So as I rotate this, you'll see that they interact more as if they're balls. You won't see objects going inside the spikes. And it doesn't matter that much, I think, for a kaleidoscope. The matter.js library does support defining polygons, so you can do that. The problem with doing that is that just using the physics engine slows down your frame rate. I'm pulling a frame rate of about 20 on this computer on the non-physics kaleidoscope, and on this one I'm pulling about a 15 when on a good day. So the more you complicate the physics, the more the frame rate's going to go down. So I'm just modeling things as balls right now. If I turn off down, this behaves very similar to the other demo where changing the rotation angle is really just changing the gravity angle. So if I point the gravity in the other direction, the stuff moves around. But I'm doing an additional trick here, which is I'm rotating, when the down button is pressed, and I normally keep it pressed, I am rotating the entire display so that gravity is always pointing down. And so the effect of changing the gravity also rotates the display. And this is very similar to what happens when you rotate a kaleidoscope object cell or a kaleidoscope itself. So without down, if I turn on the wedge feedback, you can see the mirrors here, and I'm just changing the gravity, and the mirrors aren't moving. But with down rotated, it is as if I am rotating the entire kaleidoscope, and the mirror aperture is also changing, which again is closer to what happens with a real kaleidoscope. So if I turn the mirror display on, turn the wedge off, and then change the rotation angle, we'll see it grow as the items fall into the mirror, which is a very typical kaleidoscope kind of thing, which is very nice. Like the other kaleidoscope, there is a support for feedback, so you can have a kaleidoscope made of kaleidoscopes, or a kaleidoscope made of kaleidoscopes made of kaleidoscopes, and so on, so you get a rug. One feedback level is kind of nice, and then there's a recursion scale. If you go way up here, you can play with the recursion scale and get different patterns like that. For now, I'm going to keep the feedback off, so it's more like a traditional kaleidoscope. And then I should also talk about the rotation speed. So this just controls the overall angle, easier to see when I turn off the mirrors, and you can see it rotating it. But if I let it go, it is also possible just to get a constant rotation. The problem with not having a little bit of rotation is that the kaleidoscope eventually settles and it doesn't change much. And so this just adds a little rotation. You can see it happening here. If I do a lot of it, you get more of it. And that way you get constant movement and it doesn't just settle and become static. So there we go. That's a little too much. So what I like to do is just kind of destabilize it and then maybe have the rotation speed down here. And that'll keep it interesting. Now, there's one other thing going on, which will be easier to see if I turn off the mirrors again, and that's the color. You get randomized colors in this kaleidoscope. So sometimes you get a lot of different colors like this. And sometimes you get a more uniform palette. So you can see what's happening if I press the color feedback button. It shows what I'm doing. So the colors are being generated using a hue, saturation, brightness gradient, which is controlled by 3 sine waves. And the parameters of the sine waves are 2 per sine wave, which are phase and frequency. And the phase controls where the sine wave starts in its cycle from 0 to 2 pi. So this is where I have the arrow pointing here. It's the beginning of a sine wave going up to pi divided by 2, pi, and then back up to 2 pi. So phase controls where in that cycle it starts, and it's a random number in that range. And then frequency controls how fast it's going. So the ones with higher frequency numbers, there's more bumps in them. So the reason this one doesn't have a lot of variations in color, you don't see any greens or blues, is because the frequency of the hue sine wave is quite low. So you get more uniformity there. And you get different combinations. Here's a nice black and white one where the saturation has a low frequency. So we're not getting high saturated colors. Take a look at this one with the mirrors. Pretty nice. Spin it. There we go. Let's give it extra sides. Woohoo! So that's the kaleidoscope. And I have plans to do a modified version of it in which I'm using small circles that are threaded together like beads to make little cluster shapes. And I don't know if it's going to kill my frame rate. We'll see. But basically, it involves using the physics engine to connect balls with threads or springs, which will create these little interesting shapes. And it might look interesting. We'll see. I haven't tried it yet. But you'll see it appear in the repo if I manage to pull it off. See you next time.